So we'll get started today, and we're going to be viewing the NC editor today and going through all of the components to that. So I'm going to direct you guys. I know you're on the support page, but if you want to open a new tab and follow along on BobCAD.com, we create an article in advance to sort of highlight everything we're going over in the webinar. So if you go to BobCAD.com and go to news up at the top, the very first article is an article on NC Editor that we're going over today. BobCAD Camp articles, the NC Editor, your new best friend in G-code. So if you open up that article, it tells you exactly what we're going over today, and all of, I'm not going to read everything here, but I'm just going to review the highlights that we're going over today. A clean custom workspace. So in the older versions of BobCAD, we used to use the Predator software program for NC editing. Now we've created our own NC editor, and I think it's a much more user-friendly program, cleaner, easier to use, and just easier to find what you're looking for in the software program we're looking at today. File handling that doesn't miss a beat. So when you go to File, you can go to a new file, Open. You can compare two documents in our NC Editor Pro that we're going over today. And I'll show you a little bit the difference between the Editor Standard that comes with the software program and the Pro that offers simulating and things like that. Then the next topic is editing tools. So being able to go to the different tabs and then be able to edit your G-code, find and replace tools and things like that in the software program. Simulation. So again, going over the NC Editor Pro later on in the webinar today, being able to backplot the G-code line by line, and NC Editor will actually read the G-code and plot the point with the tool that you have in the simulator to be able to make sure that there's no collisions and that there's nothing that's incorrect in the G-code itself. A job setup system that gets it. You're able to simulate your stock, your tool holder, and everything to be able to read the G-code and make sure there's no collisions. And speaking of communication, that has to do with the DNC transfer. So you're able to use an RS-232 communication in NC Editor, just like in the Predator software that we had before. So you're able to set the port number, baud rate, and all of those settings to send or receive through a cable through your computer or a Wi-Fi connection if you have that setting as well. Code fully understood. You can set a template for looking sort of like, not a look ahead option, but being able to look for like a find and replace option, looking for a certain G code or M code to find and replace, or just find what the, if there's a certain feed rate you're looking for to be able to modify that G code. So that's the article in a nutshell here. You can read through it at your leisure after the live event today and be able to read even more about the NC Editor. But we're going to be going through those topics today. And I'm going to go through the BobCAD software program first, going through drawing so that you can follow along. We're just going to make a 2-inch by 2-inch square here, create a profile operation so that we're able to read the G-code together and modify the G-code in the NC Editor to see exactly what we're doing here. So I opened a new file in BobCAD V37. You could follow along in an older version if you have it, but as long as it's new enough, past few years, that has the NC Editor to look at today. And inside of BobCAD, I go to the top and I go to Create 2D. I go to Rectangle. I'm just going to do the basic 2-inch by 2-inch template that we have here for a rectangle. And down towards the bottom, under Option, I'm going to sketch it so the bottom left corner is at my CAD origin location. And then I'll click OK. So I've got a 2-inch by 2-inch square where the bottom left corner is at X0, Y0. And then I'm going to cancel out of the rectangle function. And then I'm done with my CAD side of things. I'm just doing a basic 2" by 2" square here. And we're going to get into the CAM side of it now. I'm going to go to the top. I'm going to go to CAM. And then I'm going to a new job. The first icon all the way on the left side here. Click on new job. It'll be a milling job type. And the machine will be the BC3X mill, which is my BobCAD 3-axis milling machine, a generic milling machine and G-code output, a generic G-code output formatted for a Fanuc-based G-code. And then I go to my stock wizard. Now, if I had a finished 3D model to view in simulation to make sure everything is cut to size, I could select it here, select my 3D model, and then go to the next page. I don't have a 3D model in my CAD drawing here, so I'm just going to go to the next page here without a selection. And then I'm going to define my stock. Now I'm going to look at my stock on an angle in an isometric view by using my mouse here and clicking and holding on the scroll wheel and then moving my mouse over to see at it on an angle. And again, this is a 2" by 2" square, and it creates the stock around my drawing automatically. If I type in different numbers in my dimensions here, let's say 4 by 4, and then I hit calculate stock again, it's just going to calculate the stock around my square stock again. So I type in the dimensions, the X and Y values, and the thickness here of the stock in Z. And I'm just going to leave it at the default numbers here, 2" by 2" and 1" thick in Z. And then down towards the bottom, I'm going to go to my next page. My machine setup. This is where I am defining my work offset, my G54 work offset. And it starts at the CAD origin location, which is at the bottom left corner of my stock, on top of the stock here. And I'm just going to leave it there just to show you. You don't have to follow along here and change the work offset, but if I wanted to, let's say I wanted to set the work offset at the top here, I could click on origin over here on the left-hand side in the machine setup, click on any point here for my new G54 work offset. I'm going to highlight it again and go back to my CAD origin location to line things up with the CAD and the CAM coordinates here. So when we look at the G-code coordinates from my G54 reference point here, this is going to be X0, Y0. And for an example, the tool is going to come down and then it's going to move across to X2, Y0 here. And then it's going to move up to X2, Y2 up and then move around the rectangle. So we'll click OK. And we've got everything set up for CAD and CAM now. I've got a 2" by 2" square. I've got the stock around it in my CAM tree over here on the left-hand side. I've got my machine set up at the bottom left corner of the stock. And then I right-click on Machine Setup 1 to go into all of my milling operations. And we have our drilling, tapping, counterbore operations. We're going to skip that today. We're just doing a basic profile operation to look at the G-code of a profile around this square. So I'm going to go to Mill 2 Axis. I'm going to select my geometry. I'm going to go back to a top view by clicking on this icon towards the top here. And then I'm going to window select around my square to select all 4 lines for my geometry selection. I'm going to scroll down and click OK. Brings me back to my geometry selection page. Well, I'll go to the next page. I'm going to set my total depth. I have my stock as 1" thick, so I'm going to type in 1" for my total depth here. Go to my next page. And it brings in a profile rough and a profile finish. I only want to do one pass. I'm not going to, bog us down on too much G-code to look at today. So we're just going to do a profile finish operation. So I'm going to highlight the profile rough, and I'm going to delete that operation here. We're doing a profile finish. And then all of these settings, setting up for tabs along the profile, setting my work offset number, Setting my tool, I'll leave as a 1/2 inch. For now, we'll leave the compensation on left. I'm going to just do one pass. I'm not going to have a lead in or a lead out. Should be set default to vertical here. Corner types, machine sequence, all of these settings here are going to be left as the default settings here. So I'm going to hit compute. Now it's offsetting on the inside of the path. I could either go back into the feature and change the offset from left to right, or I can change my direction of the cut from counterclockwise to clockwise by right-clicking on default change start point, reversing my direction, and then computing the toolpath again. So now it's cutting on the outside of the path. So we'll take a look at the G-code here with the compensation set in the G-code. I'm going to have to move myself here so that I'm not in the way. There we go. And now I'm going to go to the top. I'm going to first start my simulation to see the simulation of the profile around the stock. So up at the top of the screen here, towards the middle, I'm going to click on Start Simulation. It'll open up my simulation where I can hit Run. It's going to go around, and so it actually goes up and then over and then down and then over to the left and then lift back up. I'm going to close out of my simulation. I'm going to hit Post. It'll generate the G-code over here on the right-hand side, and we'll read some of the G-code here before we get into the NC editor. So first is my % sign for the start of the program, and then all of these comments here. And then after all of these comments is our safety line of code with line number 1. And I can look at it a little bit bigger with the text here by moving my cursor into the window here, holding Control on my keyboard, and zooming in or zooming out with the scroll wheel. So for you guys to look at my G-code a little bit better here, I'm going to zoom in a little bit. We're going to look at line number 1. G00 is a rapid move. G17 means we're on the top plane, coming down with the tool. G40, G49, G54 is a work offset. G80, G20, G90. These are all G-codes that are telling us that we're in inch mode, that we're in incremental versus absolute. I think we're in absolute coordinates here for this post-processor for the BC3X mill. And safety line of G-codes for that information before we start running the operation. Then we have some other comments. First cut, first tool. Tells us that we're doing a profile finish operation. Then it tells us tool number 1, tells us the tool size. And then it tells us, now that there's no more comments, now it's line number 1. I'm sorry, line number 2 now, after the safety line. And then tool 1, MO6. So it's calling out tool number 1 for the tool changer, MO6, MO8 to turn on the spindle, and then G54. So from that reference point, it's going to go to X negative 0.25, Y negative 0.25. So that is at this location right here. So it's offsetting for half of the size of the tool of a 1/2 inch cutter. It's going to offset over in X to the left 1/4 inch, and then offset 1/4 inch down in Y 1/4 inch to get to this point right here. Then from wherever the tool is up in Z, it's going to come down in Z to Z 1 inch above the G54 location of this corner right here. And then it's going to go down to Z.2, our rapid plane. So it's going to rapid down to this location. It's going to feed down to the feed plane of Z0.1, and then it's going to feed down into the stock down to the total depth of Z-1 at a feed rate that I've set on the tool page of about 44 inches per minute. Now, what else do we have before we get into the full profile around? I was going to mention something. I'm going to go now to make things easy for us. We're not going to have our compensation, right? I mean, we're going to see that we're at negative a quarter of an inch, and then we're going up to 2 inches plus a quarter of an inch for our compensation, over an extra quarter of an inch. So that our numbers are a lot easier to see here, we're going to turn off the compensation. So I'm going to right click on the feature here in the cam tree, and I'm going to edit. I'm going to go to our tool page here. And the very next page after the tool page is compensation. I'm going to turn it off. So we're just having the center line of the tool going around the square. It would make it undersized by a quarter of an inch on each side, but just for ease of use for the G-code to be able to read it, we're going to turn it off for now. I'm going to go back to the tool page, and we're going to look at the feed rates here and spindle RPM so that we can look for our spindle RPM. I'm going to set it to 5,000. For our cutting feed rate, I'm going to set it to, let's set it to 88. And for our plunge feed rate, let's set it to 66. So we're going to easily find these numbers in the G-code: an RPM of 5,000, a cutting feed rate of 88, a plunge feed rate of 66. Then I'm going to hit compute. It's going to blank out the posting window again because we have modified the operation. And so when I hit post, it's going to bring the new G-code into the posting window. I'm going to scroll down past all the comments here, past the safety line of code for N01. We get to N02 where we still have tool number 1, MO6, MO8, our G54 reference point, and now we're at G90, X0Y0, spindle speed of 5,000 that we set, spindle speed of 5,000 RPM. We're going to go down to Z1, Z.2, Z.1, Z-1 of a plunge feed rate of 66. And then we're going to go up in Y to Y2 with a feed rate of 88 inches per minute that we set as our cutting feed rate. And now, before we get into NC Editor, one more thing. I'm going to backplot the toolpath in our BobCAD software program. So under any feature, we have an operation like this profile finish. I could right click on and then go to backplot, the 5th option down. And now I can plot the points very easily here in the CAD window as I'm following along in the posting window on the right-hand side. So right now, my current tool location is at X0, Y0, Z0.2. So we're already at this rapid plane on line number 7. My next steps, I'm going to hit next in the backplot over here. Instead of pressing play and playing through the backplot, I'm just going to single step through it. So my next step is Z0.1. Next step is Z-1, just like we have in the G-code here, down to Z-1, feed rate of 66. Then we're moving up in Y 2 inches, feed rate of 88. And you can see there's not a feed rate on the next line. So what it's doing is it's just outputting the same feed rate until it changes from a feed rate of 88. So it can be assumed that this is a feed rate of 88 on the next line, even though it's not printing it in the G-code. And that's called modal or non-modal. So since it's not printing it, it's either modal or non-modal to where it doesn't need to output it for this specific machine. For some machines, it does need to be output on every line of code. For this one, for Fedunk, it doesn't need to. So next step, X2. Next step, down to Y0. Now here it is with modal versus non-modal of not needing to output X0, Y0. It could be understood that it's just moving, that it's staying at X2 and going down to X2, Y0, and then going over X0, Y0 without having to add the Y0 on this line, on line number 13. And then after it gets to X0, Y0, then line number 14, it's going to move up to Z.2 above the stock, and then up to Z1. It's not in the back plot here because it's done machining in our back plot in the CAD side of it. And then MO9, MO5, turning off the tool, G90, and then T1, MO6, it has T1 for the next, pre-staging for the next milling job. And then the comment end of file, M30, end of program, and the % sign at the beginning and the end of the G-code here. So if you guys have any questions with the G-code so far, please let me know in the comment section. We'll be getting into modifying the G-code of the profile around the square here in our NC editor next. I think that's about it. Yeah, so I'm going to right-click on the posting window here. Now, we could save it as an NC file and place it onto a flash drive, send it over to the controller from here, or we can modify the G-code by right-clicking and going to NC editor. It's going to open our NC editor in a separate window. So if I wanted to put it on a separate monitor, you can see it's a separate window here. I could move it over to my other screen here. You can't see that one, so I'm going to keep it on this one. And you can see a coordinate system here, X, Y, Z, red, green, and blue here, sort of in the workspace over here on the right side. I can zoom in, zoom out. Now, this isn't going to be anything for the standard NC editor. This is going to be for the NC Editor Pro that you could upgrade to be able to simulate the G-code here in the NC Editor. So before we get into that, we'll get into all the standard options here first. As we have in the news article, up at the top, we have our user interface, very similar to BobCAD, where we have the File tab to be able to create a new G-code program in NC Editor, open an existing file, save this file separately if we've modified the G-code in here. Options, we can set up some keyboard shortcuts, mouse controls, things like that. We can print a file, a text file, to a printer and be able to have a hard copy of it, or we can close out of NC Editor in the File tab. Then we go over to the Edit tab here. I don't know if you can see the very top here. It might be cut off. Sorry. So we've got our File tab. We've got our Edit tab next. And we have... There we go. And we have the Edit tab. So I can cut, copy, paste, all of these options. If I were to highlight some text here in the G-code, like this comment, job note section, I've highlighted that. I can copy and paste it. I can select all in the G-code, copy and paste. Some other edit tools we have over here. So let's say if I've deleted job note section, just hit backspace. Once I've highlighted it, I can undo or redo. And those are all within the scope of Windows functions also. So if I wanted to copy something, I could do Control-C to copy, Control-V to paste, Control-Z to undo, Control-Y to redo. I think we have Control-F to find. Big icon right here also. We can find and replace. I'm looking for G01 and I want to replace it with G00, I can find the next one and replace it. I can also replace all of the G01s to G00s, things like that in the find and replace. I can go to a specific line in the G code if I've got a whole lot. We're getting into mill 3 axis, for example. There's going to be thousands of lines of code, so I can go to line number 1000 if I wanted to here G code, and brings me right to that location. The next option here, under this group block numbers, I'm going to move myself again because I'm in the way of the G code on NC editor. Okay, so next one, under block numbers, we have resequence line numbers. So what that will do is if I've modified, let's say I want to get rid of line number 5, 6, 7, 8, 9, and 10. Let's say it's just G code that I don't need in the file. I can highlight it, hit backspace on my keyboard, and we've got a space here, and we've got a break in the line numbers, so it's going to be hard to read if I'm looking for line number 4, and then I'm looking for the next line of code after line number 4. It's line number 11. Let's say I want to resequence them. That's what this resequence line numbers button is for. Once I click on it, it's going to change from 4 to 11. It's going to be 4 to 5, 6, 7, 8, for example. And I'm actually going to make the G code a little bit larger for you guys to see. I can hold Control and use the scroll wheel in here to make it larger as well. So again, you'll see it change from 4, from 11 to 5, from 12 to 6, and so on once I click resequence line numbers. And now we're at 3, 4, 5, 6, 7, 8, 9, 10. Remove blank lines, so you can see between job note section and the comment for first machine setup. We've got a space there. We've got a space on the next line. If I want to get rid of all of these spaces, I can just click remove blank lines. Now everything is line by line there. And then the next one is remove spaces. So if I click on that, all of the spaces in the program, it'll be hard to read if we're looking to read the, like job note section. Once I hit remove spaces, it'll be a little difficult to read each line here. I can remove spaces for everything there. And then next is feed rate. So let's say the next feed rate, let's say I select, I don't have a feed rate anymore because I've deleted it out. So I'm going to undo all of these changes I've made. I go to this feed rate of the plunge feed rate of 66. I click on that line here. I click on feed rate, and then I can change from a percentage. It only gives me a percent sign. Let's say I want to double it from 66 to 132. So I type in 200%, and it's on the selected line already that I want to change, and I click OK. It'll change it from 66 to 132 there. If I want to change all of the feed rates to double what they are, I can select the whole file and click OK. We've doubled the plunge feed rate from 132 to 264, and we've doubled the feed rate of the cutting feed rate going around the square from 88 to 176 here. That's the whole file. Until next tool change means it'll be all of the feed rates until we get to the next operation with the next tool. So I'll hit cancel there. I'm going to undo those changes again. And then we also have the same concept for spindle speed. We can modify the spindle speed that we select. Let's say I want to double the 5,000 to 10,000 there. All right, same kind of concept there. Edit values, if there was anything else, let's say I wanted to change the tool 1 maybe to tool 2. I can edit the value, select the letter here for a value of t. I can add, subtract, multiply, divide. So if there was a spindle speed, an x value, a g code or m code, or like we have here a t value, I wanted to add 1 to it and click OK. So from tool 1 to tool 2. If I wanted to change all of the tools in the file, I could change all of them. So I needed to resequence them from tool 1 to 2. Tool is going to be tool 3 now. Tool 3 is going to be 4. And I wanted to change them all here. I just click OK. Changes them all for me from there. Now I'm going to undo all of my changes. I'm back to the original G-code file. Let's see. So we've got a question, change feed rates, removed the decimal point. That's a good point there. So let's see that in action. Let's go to my plunge feed rate of 66 on line number 9. Change my feed rate, change it to double it, so 200. It does change the decimal. It does get rid of the decimal value. So that's a good point. If you need the decimal value for your machine, you may need to type the decimal point again after you've doubled it. Or if you wanted to do it yourself, of course, you could get rid of the feed rate changer here, is what I'm going to call it. And you can just type in the number. Let's change it to 100 here. It'll keep the decimal point for you. But yeah, good point. You can change, when you change it for your feed rate or spindle speed or whatever you're changing in here, it does get rid of that decimal point. So next, we've got our View tab. So our View tab would allow us, if we have multiple operations in here, we can collapse all of the operations. You can see there's a minus button. It's really hard to find or really hard to see, but if I zoom in further, you can see line number 2 with tool 1 MO6 to the left of it. We have a minus icon. So if I click on that minus icon, it's going to collapse that whole operation, the profile that we did from tool 1, line number 2 to end of operation tool 1, line number 19. So that could be really helpful. Again, for an example, getting into 3-axis milling is going to change. It's going to collapse the whole operation. So let's say I did a 3-axis milling, a planar operation, could be 1,000 lines of code. I could collapse the whole operation to get right to my next operation there. So that's the collapse and expand option. Next would go to your next tool, or you go to your previous tool, call out. Comment will go to your next comment or your previous comment. And compare would be if you wanted to compare this NC file with another NC file that I have in here. Let's do BobCAD 2. I don't know what's in here, but it's pretty similar. It's a mill 3-axis machine and post-processor G-code output. So you can see all of the same comments are in here. But anything that's highlighted is going to be different comparing the two G-code files. So I'm going to get rid of this. How do I get rid of this file? I'm going to... So in the compare... Oh, there we go. Perfect. So if I just hit compare again, it'll get rid of it. And then next will show me the next line of code that has a difference in the G-code for each one there, or previous. And then when I hit compare again, you can see it's highlighted. So once I hit compare again, it'll get rid of the compared file, we'll say. Eric, good point. So you said when I go back to the edit tab, and I go to one of these modify tools, it's automatically in metric. The NC editor is always in metric. I guess you could say technically like by default, but all of my G code is in imperial because that's how I output it in BobCAD. So, and technically percent sign, a percentage isn't going to change anything whether I have it in metric or imperial. But yeah, that's a good point. I if I'm in imperial, I do want to leave it here as imperial. And once I change, double my feed rate, it's going to change that on that line. And but yeah, whether I have it in metric or imperial, a percentage isn't going to affect that unit amount. But yeah, if you wanted to change from a feed rate, especially like editing the values, you want to change metric to imperial, and you want to change like a feed rate or anything, you want to make sure that you're in imperial there. All right. But yeah, good point to make. If you guys have any other questions or comments, let me know in that comment section, and we'll run through any questions that you guys may have in here. NC Editor is a very, I would say, user-friendly and very, I don't want to say basic, but there's few options in here. Like we just went over the Edit tab, the View tab to find and replace, collapse or expand any operations, find the next tool call out, find the next comment, and also be able to compare two programs with each other. So if you've made some changes and you want to compare the two programs and see what changes you've made, you can compare the two. And then we get to the next tab, Simulate. So yeah, we're almost done. We've only got 2 more tabs here in the NC Editor. So if you guys have any questions, please let me know. More than happy to answer anything. So we're on the Simulate tab. I'm going to, this is getting into the NC Editor Pro of things. So we're able to backplot and able to simulate just like in the BobCAD software program, but there's one difference. If I go back to BobCAD, I go to Simulation. This is not the same simulator as in the NC Editor. And the biggest difference is when I'm simulating or backplotting in BobCAD, what BobCAD is doing is it's only going to simulate or backplot the toolpath. So if I back out of simulation here, and I go to the backplot in BobCAD, again, BobCAD is just looking at my toolpath here in pink and in green, and it's just going to follow along the visual of the toolpath here in BobCAD. Doesn't do anything with the G code over here on the right hand side. It just looks at the toolpath in BobCAD and follows along it. So if I've made any changes in the NC Editor or any changes later on in the NC code, it's not going to be any changes in BobCAD here. It's just going to follow along the graphics of the toolpath. Now, when I go into my NC Editor, and if I make changes here in the G code, the backplot and the simulator here in NC Editor will read the G code line by line and will simulate the G code. So that's the biggest difference between the simulation in BobCAD and the simulation in NC Editor. The NC Editor will actually read the G code here. So if you've got any discrepancies in the G code, you've got an incorrect Z value, which I'm going to show you guys here in a second, and it will read that line and it will tell you, hey, there's a collision here. You don't want to do that. So up at the top, at the very center here, you can see your different views. So I'm going to look at it from a top view, so that now I've got my X and Y values, X being left and right, Y here in green being up and down. And I'm going to zoom in to the corner here where I should be able to see my stock that comes in when I click my verification button here. My back plot, if that's only highlighted, and I hit reset and hit play, it's just going to show my tool, and it's going to show my tool path. Just like in BobCAD, right? You've got your back plot where it's just going to show the tool and the tool path in my CAD workspace. Okay, so that's back plot. If I turn that off and turn on verification, it's going to show my stock and it's going to show my tool here as well. Now you can see I'm not in a top view anymore. I can, it's a little different to rotate around in NC Editor. Instead of the scroll wheel, I'm clicking and holding on the left mouse button to look on an angle here. And I've got my simulation run speed up at the top, so I'm going to slow it down. I'm going to hit reset, so we're back to the original stock. And then I'm going to hit play to play through it here. So the tool's up here. Speed it up a little bit. I think we can do that. Yep, okay. It goes really fast in the NC Editor. So what I'm going to do actually is hit reset. And I'm going to step through it just like I did in the back plot of BobCAD. So I'm going to hit next, next, next. So I'm skipping through all of the comments here. You can see it's highlighted here in red of the line of code I'm in the NC Editor. So now I'm on the safety line, N01, the safety line of code. Then I go through the comments, and now I'm at Tool 1, M06, M08, G54, X0, Y0. So here's the tool at this safety location from the home position of my machine. And then it goes down to Z1. And then it goes down to Z.2. And then it goes down to Z.1. And then it's going to plunge down the feed rate of 132. I've doubled it from 66 in the NC Editor. And then it goes, it's plunging down to a depth of Z-1. Then we've got our feed rate of 88 inches per minute in the cutting feed rate up to Y2. Same feed rate all the way around. I'm moving over X2. I'm moving down Y0. So you can see it's in absolute coordinates because we're not going in incrementally. We're going down 2 inches in Y, but in absolute coordinates we're at the Y0 position, and then we go back to the X0 position. And then we go up to Z.2, we go up to Z1, and all of these lines of code, M09, M05, M06, and then M30 to stop the program there. Now, at the end of the operation, let's say instead of Z-1, I go around the profile. You can see I'm actually not even stepping through anymore. I'm just clicking on each line, and it's showing me the preview of it, which is really cool. And let's say instead of going up Z1 and ending the operation, let's say I've got, type in Z-1.5. So let's see, the tool might be long enough to be able to get down there. So let's do Z-2.5. So I'm an extra 1.5 inches down from the bottom of my stock. I've typed it in there. So when I hit reset and I step through and see that, it's going to read that code and it's going to actually go to that position. So I'll hit reset. I'll hit next block all the way through. Gone through the comments here. We're at X0, Y0, Z1, down to Z.2, down to Z.1, down to Z-1, up to my absolute coordinates of X0, Y2, X2, Y2, X2, Y0, X0, Y0, Z0.2. We're up out of the stock. We're up out of the stock by 1 inch, but now from our G54 work offset, we're down 2.5 inches. And you can see the tool holder hits the stock. You can see in the comments under the G-code program, kind of hard to see. I don't know if I can zoom. No, I can't make this larger, but you can see it says line number 35 Z negative 2.5, a collision happened of type arbor crash when applying rapid move from x0y0z1 to x0y0z negative 2.5. So it gives you an error, and it shows you that location. And after it's come out of the tool, after it's come out of the stock, it will show you red wherever there's a collision on the stock there. So this is all great information in our NC Editor Pro to provide you with reading the G code line by line. And if there's any collisions within the G code itself, it will show you that collision, and it will give you an error message before you run it on the machine there. So if you guys have any questions with that, please let me know. That's pretty much what we're going over with the simulation tab here. I'm going to move myself so you can see the rest of the tab, rest of the options. You've got reset, play, pause, next block, stepping through. You can fast forward through the simulation. We've got our back plot, which will show the toolpath here, and the verification, which will show the so the back plot, which will show the toolpath, the verification, which will show the stock, the different views, top, if you want to look at it from a front view. You got your controller type here, so if you've got different machines that you're outputting from rather than just a Fanuc controller, you can select Haas or different options there. Different coordinate systems, if you're setting different work offsets. You want to show your axes and the values with the axes here, you can show those. If you want to show the tool and the holder, or hide the holder or hide the tool here, you can do that. And then the last button here is job setup. And this is where you can set up your tool. Now, by default, it brings in the tool from BobCAD. So if you wanted to change the information here, you can definitely do that. If you wanted to change the tool holder or anything else with the machine, you can set up tools, tool adapters. You can change your stock. The stock does come in, it imports from BobCAD, but if you wanted to change the file, you can go here to Browse, and you can select an STL file to select as your stock. And yeah, set up a lot of different options here in your NC Editor to be able to set up your tool holder, your tool adapter, different things on the machine like a fixture and things like that in the job setup you can set up for, and also your specific stock here as well that you're cutting from. Then we go over to the Tools tab. And here is, this is in the NC Editor Standard and the Pro. So if you don't have the Pro and you weren't able to follow along with the NC Editor Pro of the backplot and simulation, you can at least follow along with the Tools tab in the NC Editor Standard. We have Start DNC Transfer that you can click on, and you can set your connection, your communication from a computer, and you can have it plugged in, if it's a 9-pin connection for an older computer, or if it is, from a USB to a 9-pin connection to the machine. You can set the port number that you're going from the computer, set the baud rate that is going to be set at the machine. You have to have the same baud rate as you have on the machine there. So you got to find that in the controller, find what the baud rate is, parity, data bits, stop bits. All of those options are by default on the machine. So you have to find those numbers, set them in here, and then you can send to the machine. So the machine has to be ready to accept G-code, and then you hit send here, and it'll tell you a preview and transmission successful. You can also receive a G-code file from a machine if you've got a G-code program you want to place on your computer and maybe print it out or have it for next time. You can receive from the machine as well. It's saying here that there's no machine to receive from, so it's not gonna like that one. Also, under Tools and Start DNC Transfer, you have another tab up at the top, Communication Protocol. You have different settings for drip feeding. So again, this is getting into RS-232 communication. If you wanted to wait a certain number of seconds before it sends the next character in the G code, you can set that here. I normally do line delay. So it will wait a certain number of milliseconds until it sends the next line of code for drip feeding. If you have an older machine that doesn't have enough memory to take a full G-code program all at once, you can wait a certain number of seconds every time, or a certain number of milliseconds every time to send each line of code there. Also, you can add a % sign. You can add G-code or comments before the program, like, hey, is this working? And then you get that comment before the whole G-code program, and in front of each line of code, you could add something. Behind each line of code, you could add something. And at the end of the program, you could say, it worked. Woohoo. And so, yeah, and then you send it. You'll have that comment at the beginning of the program. You'll have that comment at the end of the program, so that you could add that in before and after the milling job, the NC program. So we'll close out of the DNC page here. We have toolpath statistics. So I believe I have to run the simulation first. So if I go to Simulate tab, I hit play. We've got the profile operation here. I go to Tools and I go to Toolpath Statistics. It has the statistics of how far down I've gone in Z, how far over I've gone in X and Y, the length of the tool path, so the length of travel of the profile operation, total of 8 inches that it moves across, and a cycle time of 3 inches. And then it gives us a list here that I could export. It exports it as a text file that I could print and give to my machinist that's running it, and let them know the distance traveled, the cycle time, and feed rate and spindle RPM, things like that. To be quite honest with you, with the NC editor, that's a really basic setup sheet, we'll call it, under toolpath statistics. But what I like in BobCAD, we have an even more sophisticated one, I would say, if you're interested in looking at that one. You can right-click on the milling job. You can go to Generate Setup Sheet, the 4th option down. And the full setup sheet, there's a few options down here, like the mill tool list will give you a simplified one, similar to what we had with the toolpath statistics in NC Editor. It tells you the file name, the NC file name, the program number, and the tool list here. And if I go to Generate Setup Sheet, Mill Tool List Simple, I look at that one a lot because that gives you your tool list and types it out for you. And other than that, if I go up towards the top, Mill Setup Sheet Simple sort of has it all in text. It gives you the stock information, the tool list, and then it gives you the operation list. The feed rate is going at, and those kinds of options there. I normally go to Generate Setup Sheet under the milling job, and then Full Setup Sheet. This is a really convenient one where it gives you, up at the top here, it gives you the cutting distance. So this is all easy to read here with this one. Like this one. Number of tools, number of operations, total cycle time, 6 seconds. Gives you a preview of the file. Gives you the stock data. It's 2 inches by 2 inches by 1. Gives you the tool list and gives you the operation list and the cycle time for each operation here. Gives you the tool data, the tool number here, and the feed rate and spindle speed of each operation with that tool. So you could print this and send it to the machinist if they need a printout of all of the information of your milling job there. So anyways, we go back to the NC editor. If you guys have any questions with what we've gone over with the NC editor, please let me know in the comments section. But we've done a basic overview of everything in the NC editor here. It's a total of 5 tabs up at the top. You've got your file tab to create a new G-code file here. Open up a G-code file that you already have. You can save what you've modified here. You can set up some different shortcut keys, and you can close out of NC editor or close out of a G-code file altogether here. And then after the file tab, we've got the edit tab where you can cut, copy, paste, undo, redo, find and replace, go to a specific line in the G-code, and then some other modify options. You can resequence line numbers, you can modify a feed rate or a spindle speed or anything else in the G-code here. Up at the top, the third tab over is view. You can collapse or expand some operations. You can go to the next tool. You can go to the next comment, and you can compare two G-code programs if there's specific G-codes or M-codes you're trying to look for. Let's say you're trying to modify the post processor, and there's an M06 and then there's an M07 on the next line, and then you compare the two files and you're like, okay, I've got to add M07 after this to my post processor so that it outputs every time, because that's what the machine wants to see as well. So the compare option is really helpful. The simulate tab, where you can go to a top view and you can zoom in. You can hit reset and press play to simulate and backplot the operations here. And then your tools tab to communicate through an RS-232 communication with start DNC transfer. A little more on the RS-232 communication, setting your port number, your baud rate, parity, data bits, stop bits. It has to be set up here for the NC editor. It also has to be set up in your device manager on the computer. So when you go to your start button down at the bottom here of your computer, you'll type in device manager, and you'll find some options down here towards the bottom. You'll see like USB, universal serial bus controllers, and you'll see like RS-232, or you'll see like 9-pin connection, port 1, or something like that. You'll be able to double click on one. I don't know if I have any of these. Nah, I don't have any of them. But if you double click on the hardware or firmware for the let's say it was port 1 from your USB to the 9-pin connection, you'll double click on it here, and then it will have the same port number, baud rate, and other settings that you have to have set up at that location and at this location, the same exact settings as they are at the controller. I don't think you can really change those settings on the controller normally. So you get those numbers from the controller, you type them in here, and you type them in from your device manager as well, into your device manager. The RS-232 COM1 or COM2, whatever port number you're using from your control. COM1 or COM2, the port that you're using at your computer. There we go. So start DNC transfer, and then toolpath statistics will give you all the information that you have set up from your simulation there. So if you guys have any questions, comments, concerns, please let me know in the comment section. But that's all we've got to go over today with the NC editor. I think it's a lot more user-friendly, looks a lot more advanced, a lot more sophisticated than our Predator software. It was pretty basic. This one's a lot more sophisticated, looks really nice, really smooth, and very easy to find what we're looking for. If there's any discrepancies in the G code, like a bad Z call out, it's going to have a collision. It will give you the collision in the error reporting down at the bottom. So that's the biggest difference between the simulation in BobCAD and the simulation in NC Editor. It actually reads the G code line by line in NC Editor and will give you an error report if there's any collisions involved. So yeah, please let me know if you guys have any comments. I'll sit back for a few seconds if you guys are still typing away, if you guys have any questions. But I want to thank everybody for viewing the event live today on NC Editor. We have a live event every other Wednesday. So today is April 2nd. Our next live event is April 16th. The topic is to be determined. We send a survey out and ask you guys what you want to see in the next live event. And based on the answers in the survey, we will have that as our next live event. We want to make sure these live events are tailored specific to what you want to see in the software program. We've got so much going on. We've got the NC Editor, we've got milling, we've got turning for lathe, mill turn for a lathe with live tooling. We've got wire EDM. We've got laser, plasma, water jet machining. And we also implemented drag knife in our newer version. So a whole lot in the software program that we can go over. And so if you could fill out the survey, let us know what you want to see in the next live event, and we'll go over it next time. That is April 16th. And we start 1:00 p.m. Eastern Time. All right. Well, I don't see any other questions or comments, so I want to thank you guys again for viewing the webinar today on NC Editor, and we'll see you in the next webinar. Thank you. Have a great day. See ya.